Section 6.1, Law of Sines. So the first thing we're going to discuss is finding the area of a triangle. Now we all know from middle school that the formula for the area of a triangle is half the base times the height. But if we take a look at this triangle, we have a few things going on here. So first we see that we have the right triangle here where we have A, B, and then it ends down here at that 90-degree angle. So if I look at just that right triangle, I can get the value of the height when I talk about the height as being the opposite side for angle A and C as being the hypotenuse. And really what I'm looking at is this kind of blue triangle here. And that's one way to get the value of the height. So I can rearrange that. And instead of saying that sine of the angle is equal to the opposite over the hypotenuse, what I can do instead is multiply by c on both sides and get a formula for this height. So when I go to calculate the area of the entire triangle, what I can then do is replace the height with c sine A. So we have 1/2 times the base. In this case, the base is B, times the height, which we said is equal to c sine A. So really our formula for the area of a triangle is 1/2 BC sine A. And that would be for any triangle. You can use this formula or two other formulas that we'll see in just a second to find the area of an oblique triangle if you know either the lengths of two sides and the measure of the included angle. And when we say included, we mean the angle in between. So for example, we're talking about side B and side C, and the angle we need to know is angle A, and that's the angle that's formed by those two lines. So the area of a triangle is 1/2 the product of the lengths of the two sides and the sine of their included angle. So it doesn't matter what variables we use, A, B, C, D, as long as we're making sure that we're using the sides and the angle in between them. That's that included angle. So we're going to find the area for each of these triangles. So we have a side, and the included angle. And that's really what I'm concerned with here. So that's 1/2 one side times another side times sine of the included angle. And you cannot do this without a calculator. So sine of 46, just make sure you are in degree mode in your calculator. Whether you're using a scientific or a graphing, you need to make sure your mode is in degrees, otherwise you are not going to get the right answer. Radian would give you something very different. So when we plug this in, we're going to get that our area is 35.6 yards squared. When I take a look at the next one, again, I have my two sides and I have that included angle. So I'm going to use 1/2 times the two sides times sine of the included angle. And again, with the calculator, that's going to give us about 76.3 meters squared. And lastly, again, I have two sides and I have the included angle. So I have 1/2 times side times sine of the angle. And when I multiply that out, I'm going to get that the area is about 26.0 centimeters squared.